Diodes as rectifiers. By the end of this lesson, you should be able to describe the use of diodes as rectifiers. Describe the use of a capacitor to smooth out output current and output voltage in a rectifier circuit. Two circuits, each consisting of a diode, a bulb, dry cells, and a switch has been set up. What can you say about the diode arrangement in the circuits? The positive terminal of the cells in circuit A is connected to the anode, while the negative terminal of the cells is connected to the cathode of the diode. Thus, the diode in circuit A is forward biased. The positive terminal of the cells in circuit B is connected to the cathode, while the negative terminal of the cells is connected to the anode of the diode. Thus, the diode in circuit B is reverse biased. What happens to the bulbs when the circuits are completed? Click on the switch to find out. Only the bulb in circuit A lights up. Why? The forward-biased diode in circuit A has low resistance, thus allowing current to flow and the bulb lights up. The reversed bias diode in circuit B has high resistance, thus not allowing any current to flow, hence the bulb does not light up. What will happen if the dry cells are replaced with an alternating voltage supply? A bulb is connected in series to an alternating voltage supply. A CRO is connected across the input voltage supply and another CRO is placed across the bulb. What waveforms will be displayed on the CRO screens when the switch is switched on? What can you say about the brightness of the bulb? Click on the switch to find out. When the switch is switched on, the first half cycle of the alternating voltage are displayed on both CRO screens. The bulb lights up. However, its brightness varies with the magnitude of the current. The bulb is brightest when current is at maximum amplitude. A diode is placed in the circuit. What will be displayed on the CRO screens when the switch is switched on? Click on the switch to find out. When the switch is switched on, both CRO screens displayed the first half cycle of the alternating voltage. What can you say about the diode when current flows in this direction? When the current flows in the direction shown, the diode is forward biased. The forward biased diode behaves like a conducting material. Therefore, current is allowed to flow and the bulb lights up. For the second half cycle of the alternating voltage, current will flow in the opposite direction. What will be displayed on the CRO screens? One complete cycle of the alternating voltage is seen on the CRO screen across the voltage supply. However, for the second half cycle of the alternating voltage, the CRO across the bulb shows a horizontal line. This indicates that there is no current flow in the circuit. Why? For the second half cycle of the alternating voltage, the diode is reverse biased. The reverse biased diode behaves like a non-conducting material and thus blocks current from flowing. This results in the bulb not lighting up. The diode and the brightness of the bulb when the alternating voltage is supplied. For the first half of every cycle of the alternating voltage, the diode is forward biased and current is allowed to flow in the circuit. For the next half of every cycle of the alternating voltage, the diode is reverse biased and no current is allowed to flow in the circuit. Hence, the bulb lights up and goes off alternately. What is the function of the diode in the circuit? The diode allows current to flow only in one direction, thus converting alternating current into direct current. Hence, the diode is said to be a rectifier. Based on the waveform displayed, what can you say about the rectification? Since only half of every cycle of the alternating current is made to flow in one direction, this process is called the half-wave rectification. A circuit consisting of a diode, a bulb, and an alternating power supply has been set up. 2 CROs are also placed in the circuit. What type of circuit is this? What happens to the alternating current when it passes through the circuit? Click on the switch to confirm your answer. This is a half-wave rectifier circuit. A half-wave rectifier cuts off half of the alternating current. Thus, only half of the alternating input current reaches the output. So, how would diodes be used to convert all of the alternating current to direct current? A circuit consisting 4 diodes, 2 CROs, and a bulb has been set up. What will be the waveforms displayed on the CRO screens when the switch is switched on? What can you say about the brightness of the bulb? Click on the switch to find out. When the switch is switched on, both CRO displayed the first half cycle of the alternating voltage. What can you say about the diodes when current flows in this direction? When the current flows in the direction shown, diodes A and C are forward biased, while diodes B and D are reverse biased. Thus, the first half cycle of the alternating current is allowed to flow through the forward bias diodes. The path of the current flow is from the voltage supply, through diode A, the bulb diode C, and back to the voltage supply, and thus the bulb lights up. For the second half cycle of the alternating voltage, current will flow in the opposite direction. What will be displayed on the CRO screens? One complete cycle of the alternating voltage is seen on the CRO screen, which is connected across the voltage supply. However, for the second half cycle of the alternating voltage, the CRO connected across the bulb shows a positive second half cycle of the alternating voltage, and the bulb still lights up. Why? For the second half cycle of the alternating voltage, diodes A and C are reverse biased, while diodes B and D are forward biased. The reverse bias diodes block current from flowing through, resulting in current flow through diodes B and D only. Thus, the path of second half cycle of the alternating current is through diode B, the bulb, diode D, and back to the voltage supply. With current still flowing through the bulb in this second half cycle, it continues to light up. What can you say about the diodes and the brightness of the bulb when the alternating voltage is supplied? For the first half of every cycle of the alternating voltage, only diodes A and C are forward biased, and current is allowed to flow in the circuit through these two diodes. For the next half of every cycle of the alternating voltage, only diodes B and D are now forward biased, and thus current is allowed to flow in the circuit through these two diodes. Since the brightness of the bulb varies with the magnitude of current flowing through it, the bulb lights up and goes off alternately. What can you say about the functions of the diodes in the circuit? Diodes A and C allow half of every cycle of the alternating current to flow through the bulb in one direction, while diodes B and D make the other half cycle of the current to flow through the bulb in the same direction. What does this 4-diode arrangement do to the alternating voltage supply? This 4-diode arrangement makes every cycle of the alternating current to flow in one direction, that is, the same direction through the bulb. This process is called the full-wave rectification. A circuit consisting of a diode, a bulb, an alternating voltage supply, and two CROs has been set up. What would be displayed on the CRO screens if the voltage supply is switched on? Click on the switch to confirm your answer. Waveform is displayed by the CRO connected across the bulb. The waveform indicates that the magnitude of the voltage changes or fluctuates with time between 0 and a maximum value. What can you say about the brightness of the bulb? The bulb lights up with varying brightness and goes off alternately. Why? In a half-wave rectified circuit, only half of every cycle of the alternating current is allowed to flow in the circuit. Hence, the bulb lights up when there is current flow and goes off when current is blocked off. How can the bulb be made to light up continuously? A capacitor is connected parallel to the bulb in the circuit. Click on the switch. What can you say about the brightness of the bulb? The brightness of the bulb varies slightly, but it lights up continuously. What can you say about the waveform displayed by the CRO across the bulb? The output voltage does not drop to zero even when the diode cuts off half of the input voltage. The output voltage is said to be smoothed out by the capacitor. Thus, there is a steady supply of current through the bulb. This enables the bulb to light up continuously. A capacitor consists of two parallel metal plates separated by an insulator. A capacitor can store electrical charges. A capacitor can be charged by connecting a direct voltage supply across it. What will happen to the plates connected to the terminals of the voltage supply? Click on the switch to find out. Electrons from the plate connected to the positive terminal of the voltage supply will be pulled to the positive terminal of the voltage supply. The plate then becomes positively charged. The plate connected to the negative terminal of the voltage supply gains electrons and thus becomes negatively charged. During the charging of the capacitor, there is a flow of electrons around the circuit. This will also result in current flow in the circuit. As the electrons flow, the number of charges on the plates increases. This will cause the potential difference across the plate to increase. As the potential difference across the plates becomes equal to the voltage supply, electrons will stop flowing. The capacitor is now fully charged. What happens when a bulb is connected across the charged capacitor? Click on the switch to find out. When a bulb is connected across a charged capacitor, there is a flow of electrons from the negatively charged plate to the positively charged plate. The capacitor is said to be discharging. During the discharging of the capacitor, the flow of electrons will result in a current flow. How does a capacitor smooth out the current flow in the half-wave rectification circuit? As the alternating input voltage increases, charges will be stored in the capacitor. When the input voltage supply is at its maximum, the potential difference across the capacitor is equal to that maximum voltage. As the input voltage supply decreases, the capacitor undergoes discharging. What happens during discharging of the capacitor? When the capacitor discharges, electrons move towards the positive plate. Current will flow in the same direction as the current from the voltage supply. This will produce a nearly steady current flow through the bulb. During discharging, the amount of charges left in the capacitor is decreasing. Thus, the current produced is also decreasing. What happens when the input voltage starts to increase again? When the input voltage starts to increase, the capacitor will undergo charging again until the voltage across the capacitor is equal to voltage of the input supply. As the input voltage starts to decrease, the capacitor will undergo discharging, current will be produced, and the process is repeated. This will result in the smoothing of the half-wave rectified. How does a capacitor smooth out the current flow in a full-wave rectification circuit? In a full-wave rectified circuit, the capacitor will undergo the process of charging and discharging. This will also result in a nearly steady current that flows through the bulb. Both half-wave and full-wave rectifications do not provide a steady direct current like a dry cell. A capacitor is used to smoothen out the direct current produced. The charging and discharging process of the capacitor reduces the voltage drops, thereby producing a smoother current output. The capacitor is said to function as a smoothing capacitor. An alternating voltage supply, a circuit board to place 4 diodes, a bulb and a CRO has been arranged in a circuit. 4 diodes are also being supplied. Drag and drop the diodes into the appropriate positions so as to create a full-wave rectified circuit. When the current flows in the clockwise direction In the first half cycle of the alternating voltage, diodes A and C are forward biased, while diodes B and D are reverse biased. The forward biased diodes behave like conducting materials, while the reversed biased diodes behave like non-conducting materials. Thus, the first half cycle of the alternating current is allowed to flow in the circuit through the forward biased diodes. The path of the current flow is as shown. For the second half cycle of the alternating voltage, the current flows in the anti-clockwise direction. Diodes A and C are reverse biased, while diodes B and D are forward biased. The reverse biased diodes block current from flowing through, resulting in current flow through diodes B and D only. Thus, the path of second half cycle of the alternating current flow through diodes B and D is as shown. Diodes a multi-tap transformer providing an alternating voltage supply, 2 diodes, a resistor RL, and a CRO has been arranged in a circuit. 4 sets of half-cycle voltage traces are provided. Drag and drop an output voltage trace that would be displayed on the CRO when 2 complete cycles of the alternating current flows in the circuit. Click on the Answer button to check your answer. When the current flows in the clockwise direction in the first half cycle of the alternating voltage, diode X is forward biased while diode Y is reverse biased. The forward biased diode behaves like conducting materials, while the reverse biased diode behaves like non-conducting materials. Thus, the first half cycle of the alternating current is allowed to flow in the circuit through the forward biased diodes. The path of the current flow is as shown. For the second half cycle of the alternating voltage, the current flows in the anti-clockwise direction. Diode X is reverse biased, while diode Y is forward biased. The reverse bias diode blocks current from flowing through, resulting in current flow through diode Y only. Thus, the path of second half cycle of the alternating current flows through diode Y is as shown. A circuit consisting of an alternating voltage supply, a bridge rectifier, and a bulb has been set up. A CRO is connected across the bulb. What happens when the switch is switched on? A rectified full wave is displayed on the screen. Drag and drop the capacitors in the space provided. Observe the waveform on the CRO screen and the brightness of the bulb. What can you say about the capacitance of the capacitor and the smoothness of the output voltage? The higher the capacitance of the capacitor, the smoother is the rectified wave or voltage.